What's up, everybody? Coming at you here. Casa del Conte, getting ready to rock and roll into our next section. So, as we roll here, all right, we got 8.1 and 8.2 combined. All right, we're moving into chapter 8. We're going to be graphing what we call a quadratic equation. All right, so that's y equals a to the x squared. And then we have y equals a to the x squared plus c. All right. Now, a quadratic is going to look like what we have here. All right. It's a curved function, curved graph. All right. Looks similar to absolute value, but notice it does not come to a point at that location. All right. Whereas an absolute value would look like a V. All right. These quadratics, also known as a parabola, make the shape of the U. All right, now here we go. We got a lot of stuff we got to talk about, so I hope you're honed in, ready to roll. On that graph, okay? Obviously, our graph here, we still have a y-intercept. We could have a y-intercept, all right? And with these graphs, we always will end up still having one, okay? Now that part of the U on the graph, okay, at the bottom of the curve, all right, or the top of the curve, which we're going to get to in a second, that's known as the vertex, all right? That's the focal point of our quadratic equation. We always want to know where this is, all right? The imaginary line, all right? So this line we're not going to draw on the graph, all right? But if you notice, the graph mirrors each side. So this side of the graph is doing the same thing as the other side of the graph, all right? There is symmetry on both sides. So we refer to this line as the axis of symmetry. Cuts the graph right in half, all right? Right down the middle, right through the vertex, all right? So not today, but eventually we're going to have that vertex be moving in a bunch of different locations. All right, today we're starting with it, boom, right on the y-axis, and it's not going to move off of there today. All right, keeping it simple here right from the start. Now, like we had said, this curved function is also known as a parabola. All right, so parabola is a quadratic equation. All right, they're the same thing. A quadratic, all right, it's written in the form ax squared plus bx plus c. So now here we go. We had absolute value functions, linear functions, exponential functions, and now we've added a fourth, quadratic functions. This is the standard form of a quadratic function. So for example, slope-intercept was y equals mx plus b. Absolute value, right, was the y equals absolute value of x minus h, and on the outside plus k. For exponential functions, y equals a times b to the x. Quadratic is this, all right, standard form. We know it's a quadratic function because its degree is 2. The highest exponent will be 2, all right? So that's our key. When we see that x squared, boom, quadratic equation. All right? We're going to take a look at graphing these today. All right? Now here we go. You got to follow me here because there's a lot of stuff that we are going to talk about. If the quadratic, right, the parent function, right, the basic, most basic form of the equation. If the x squared is positive, the graph is going to open up. If the x squared is negative, the graph is going to open down. Today, we're keeping the graph right in the middle. All right. Now, couple things here that we're going to take a look at. Let's change up some stuff, right? So right here is our y equals x squared. If we put a different number in front of the x squared, all right, so here we go. Let's say we put a 2 in front. All right, here we go. Don't blink, you'll miss it. Notice the graph got narrower, right? Or it's stretched. Let's continue with that. Maybe instead of a 2x squared, we make it a 5x squared. Again, keep your eyes on the graph. Same thing. It's getting more narrow, more of a stretch. All right? Now let's say we make this maybe a fraction. All right? Maybe it's not going to get bigger. It's going to get smaller. So maybe let's make it 0.5. All right? Let's see what happens. Thinking the bigger the number, the more narrow it gets. Oh, Coach Dell, would you look at that? The smaller we make that number, the wider our graph is going to get. So, all right, so that's 0.5, right? Maybe if I did 0.1, same thing, it's getting wider. Okay. Now, somebody's sitting there, and you're like, oh, well, Coach, what if we make it a negative, right? Then what's going to happen? So if I made this a negative 2x, that's a small number. Yeah, that's a small number, Coach. So that's going to be really wide. It's going to... Coach Dell, that doesn't look like it's wide. Ah. It's a negative though. So remember we said negatives open down. So the same thing happens if it's negative. And we did maybe 0.5. It's opening down and wider. All right. If it was negative and we made it negative 7, it's opening down and it's narrower, stretched. All right. And then last but not least, let's check out if, so that's the number attached to the x squared, the coefficient. All right, that was the number attached. So let's say maybe over here we add a number outside of the x squared. All right, so now we have x squared plus 2. All right. Graph shifted up 2 units. Does everybody see that? All right. It goes from here to here because we did plus 2. Y-intercept. All right. Keep all this in mind. We're going to talk about it. So maybe if I did it as a negative 2, all right, it shifts down. Started here and down. So that number that we're adding or subtracting is moving our graph up and down. And I don't know about you, but this looks like a shark underneath, like if you were like swimming underneath the shark looking up. Like this. Check it out. We did this. And we do this. It looks like a shark. Jaws. Right? I think it looks like a shark. Shall we? Let's rock and roll. Here we go. All right, so all this stuff we just talked about, changing numbers, right? Here we go. So that ax squared plus bx plus c, all right? We ain't talking about bx today, all right? We ain't going to be talking about that today. We're just focusing on the ax squared plus c, all right? So here we go. Lot of info just from those two numbers together, all right? That number in place of c is always going to be our y-intercept. So when we started adding 2 and it shifted up 2, lo and behold, that's where it crossed the y-axis. All right, if it was down 3, that's where it crossed the y-axis again at -3. So ax, the number in place of a, if it's a positive number, we know it's opening up. If it's a negative number, we know it's opening down. All right, so here we go. This is the absolute value of a. All right, if it's in between 0 and 1, all right, these are inequality symbols. So 0 is less than the absolute value of a, which is less than 1. We know it's going to be wider. The graph's going to get wider. That's when we punched in the 0.5, right? The 0.1, it got wider. This is the absolute value of a, is greater than 1. All right, meaning that number we put in, 2, 5, 7, it made the graph narrow. All right, so the bigger the number, narrow, the smaller the fraction, wider, all right? Smaller in between 0 and 1. The beauty with all this, for now, all right, when we're graphing, we are still going to need an x and y chart, and we're still going to plug in -1, 0, and 1, all right, for now, all right? Here we go. Let's check it out. So let's graph this together. It's a quadratic. How do we know it's a quadratic? Squared, quadratic. All right, we know it's going to look like a U or an upside down U. I'm making an x and y chart for this. So I'm plugging in -1, 0, and 1. I'm plugging them in for x. Make sure you put parentheses around it. You have to plug it in just like I have it here, because in this one, it's key because of that negative. You will get an incorrect number here. All right? So we plug in -1, 0, and 1. These are our y values that we get. Okay? Now, keep this in mind. These mirror. Those values will always match. They should always match. Remember, we talked about being symmetrical. It should always match. This in the middle is always going to be the vertex. Okay? Like we said, we're keeping it in the middle of the graph here today. All right, so here we go. We got our x and y chart. Let's go graph this. So when we do it, 4x squared, -4x squared, bingo. Should look like what we have here. There's our -1, -4, 0, 0, 1, and -4. Vertex, 0, 0. It's a -4x. It's opening down because it's negative, and it's a little narrower. Let's try another. All right, quadratic. Got to make an x and y chart. Plugging in -1, 0, and 1. Just because it's a fraction. Put parentheses around it. Parentheses around our x. All right? Don't forget the +2 after it. You can punch it right in the calculator exactly as is. Samoas, I know you're going to ask me, can I turn this into a 0.5? In this case, sure, Sean, you can turn it into a 0.5. Get in the habit of keeping it as a fraction though, because, for example, like a 1/3, it's a repeating decimal. All right, so we don't want to be rounding it to 0.3. We want it to be as accurate as possible. Samoas, I love you. Meat box, Samoas. You better still be doing push-ups. Samoas, you better still be doing push-ups and sit-ups, my man. All right, let's graph it. All right, here we go. There we go, got our graph. All right. This is our -1 and 2.5. 0, 2, 1, and 2.5. Vertex, right? Our numbers match on both sides. The graph moved up 2 units because of that +2. That's the y-intercept. It's a 1/2, so it's a little wider. All right. All right. You're going to give this one a go. All right, rock out. You're making your X and Y chart. -1, 0, 1. Boom, plugging it in. As you're working on it, you can kind of have an idea already. +5, it's going to be moved up 5 units. The -4 x squared, it's negative, so it's going to open down. The 4 is going to be a little narrower. Here we go. Lo and behold, there we go. When you plugged in -1, you should have gotten 1. When you plugged in 0, you should have gotten 5. When you plugged in 1, you should have gotten 1. And like we said, opening down, moved up 5. Everybody, I hope we're rocking and rolling. All right. Again, make sure the homework assignment, all right, it's due by the start of our next class. So I was a little lenient in the beginning, getting everybody used to the adjustment. So from here on out, our next class, when it starts up and when it would normally start up, you got to make sure that you have it emailed to me by then, all right? You all been doing a great job. Please keep reaching out to me if you got any questions. I miss you all right? I hope everybody's safe and healthy, and keep getting after it.